Hello Year 5 and welcome to your geography lesson. We're going to be looking at how mountains are made. Now I'm going to split this lesson into two because we're going to look at 5 different types of mountain formations. So today we're going to focus on 2 of them, and then from next week we'll have a look at the final 3. So what we're going to do is, the aim for today is to be able to explain the different types of mountains. Now obviously we're only going to focus on the first 2. So you need to be able to explain that the mountains were formed a very long time ago. You need to have an understanding of how the tectonic plates under our Earth's crust works to form fold mountains, which we're going to look at today. You need to be able to describe how the lava flow creates volcanic mountains. Now we're going to be looking at that one next week. But you need to also be able to describe how fault lines in the earth crusts move to create mountains. Now, we're not going to be looking at dome mountains or plateau mountains for today, including volcanic ones. We're going to only look at the 2 of them for today. But let's warm your brains up a little bit. Now, you have the sheet sent home to you. What I would like to do is I would like you to see if you can match the labels to the correct part of our Earth. Now, you would have done this in one of your science topics, either in last year or in year 3. So what I would like to do is pause the video. Can you have a go at labelling the correct layers for my Earth? Off you go. Okay, so the inner core is going to be the very inside, so it's the centre point of our Earth. Now the next layer after that, we have our outer core. Okay, so we have the inner core and the outer core that's then protected. And then just before we hit the crust, which is the very top layer, we have our mantle. And that's the thickest layer, okay, of our Earth's crust. So well done if you got those all correct. Now, you might be looking at this picture thinking, well, I understand it's a picture of the world map, but what are all those wiggly lines? Now, all of those lines represent different parts of our Earth's crust, okay? Now, once upon a time, it would have been one solid layer. And then as we started breaking away, all the different continents started moving away from each other. Okay, so it's not one solid layer. Now what it is, those red lines actually identify huge areas of broken up crust, and these are called the tectonic plates. Now these sit and float just on top of the mantle. So we've got our Earth's crust and our mantle, and they sit in between. So they are very easily, well, not easily movable, but they have the most flexibility for moving. Now this map actually shows where the tectonic plates are. So you can see we have some of our biggest plates that cover most of our Asian continent and our American continents over here. We have slightly smaller plates here in between. Okay, but there's quite a lot of plates, and you'll find there tends to be a lot of volcanic action around those lines on our tectonic plates. Okay, so what have tectonic plates actually got to do with mountains? So we know that volcanoes can be one way that mountains are formed, and this is what happens when that hot magma is pulled from the centre of the Earth and is then pushed through little cracks within our Earth's surface. So all that heat and energy is built up and it pushes through the cracks in our crust, and that's how one way some of our mountains, such as volcanoes, are formed. So there's 5 different types of mountains. Okay, so we have our fold mountains, fault block mountains, volcanic mountains, dome mountains, and plateau mountains. So you can see some example pictures here of each of those different types. Now each type is actually formed in a very different way. So today we're going to explore the first 2. So we're going to look at fold mountains and fault block mountains. Okay, so fold mountains occur when those tectonic plates actually collide. Okay, so imagine that the 2 plates are coming towards each other. And as the edges of the plates crumple, okay, or as they push together, they actually start to crumple. Okay, so they have like almost like a ridge that builds in them. Now the rock on the Earth's surface is what's then pushed up to create that mountain. So rather than the plates going one over the other, what they actually do is as they hit each other, they create folds, so it's almost like a ripple effect. Now, an example of this that you will know about, because we've looked at this already, is the Alps. So the Alps are actually fold mountains. So the mountains have dips as they go up and down, and that's due to that pressure from those tectonic plates. Now, it's because those pressures get moved together, it causes the sedimentary layers of rock on the ocean floor. So that thin very flexible layer of rock on the ocean floor that actually starts to wrinkle. And as a result, as those little bits on the bottom start to wrinkle, it has an effect on all the other layers. So as that bottom layer starts to wrinkle up, all the other layers actually then fold in with it. Okay, so these types of mountains are found usually between where these two continental plates actually lie. Okay. Okay, so here's an example of a picture. So these are fold mountains. This is what they look like up close. Now they're formed when the rock on that Earth's surface is then pushed up. Okay, so rather than it being a new formation of mountain rock that's come between a crack in the Earth, it's just that normal layer that started off at ground level that actually just got pushed up higher and higher. So it's that rock that's come up from the Earth's surface that's just pushed it all the way up to the top. Now here's an example, okay, a very big mountain range, okay, that spans across the Asian continent is the Himalayas. So this mountain range is a pure example of those fold mountains where along that edge of that tectonic plate along the Asian continent line has actually then just rippled, and as a result it's created all these different folded mountains that have popped up as you work your way along that continental plate line. Okay, so fold mountains are usually created because they create a fold. So they create like a bump or a ripple when those plates hit together and push up that rock from the Earth's surface. So that's fold mountains. Then another type of mountains we're going to look at are called fault block mountains. Now they're called fault block mountains because they almost come up in chunks where they go up and they go down. So they focus in different blocks as to how they're constructed. Now, when there are cracks in the Earth's surface and they open up, that larger chunk of rock can actually then be pushed upwards. So when the rock starts to expand, it gives that chance of that rock to be pushed up. And as a result, some of that rock actually falls through and it gets pushed down. So this is why sometimes you'll find mountains that have a long slope up and then have a long slope that goes back down. Now, it's usually a very sharp drop on either side. Okay, so this is an example. So you can see here how we go up and we go down. We go up and we go down. And you can see the high peaks and the steep slopes that filled in between. And you can see how each one is a block of raised mountain matter and then mountain matter that's pushed down into the ground. Okay, so this is when it forms, okay, through those cracks in the surface. And obviously that large chunks of rocks can either be pushed up or it can be pushed down. Now, an example of that is the Sierra Nevada mountain range in North America. Now, we looked briefly at this in our North America topic from last term. So you can see here the very stiff high peaks that go up and then come down and then go up and then come down. And that is a result of being along those plates where they've actually expanded and they've allowed that formation of new rock to form and push up as a mountain in that crack. But as that's then pushed up, the rock that's either side of it is pushed down. That's how you get the really steep slopes down the sides of the mountains. Okay, so you can see the difference there in that fold mountains almost have like a ripple effect. And when we talk about our fault block mountains, you can see them, they go up at a very steep angle and come down again. And that's because you have high points of the rock and lower points of the rock. And that's what creates that block formation for our mountains. So although that was a very short lesson, the next lesson will be a little bit longer because we're going to look at 3 different types of mountain ranges. Now, it's very difficult to be able to do some of the activities for this because ideally, when we would have done this in school, we would have had lots of different resources where we could have experimented making our own forms of mountains, especially with volcanoes. We could have used lots of our science equipment to have a go at making our volcanic mountains, using our Play-Doh and our plasticine to make our Earth's crust. But if you can have a go at these tasks, then please do. I'm hoping that the first one will be a little bit easier because I'm sure there'll be some form of towels or bed sheets or something that you might have at home that you can layer that's going to help show you. So for this one here, this is an example of our fold mountains. So what we've done here is we've laid out a layer of either sheets or towels, one on top of the other. And then either side, we've got 2 heavier objects. Now you might be able to do this with almost tea towels if you've got some books. So you could have a layer of tea towels and some heavy books that you could use. Now, when you then layer those layers out and you have the two books either end, as you then start to push them together, you'll see that ripple, that fold in your towels. Now, that's an example of our fold mountains. So if you can have a go at doing that one, what would be brilliant is to take a photo or even to create a drawing of your experiment and have a go at labeling the different elements with a short little paragraph about what happened during your experiment. So you'd need to label your two books as to be your tectonic plates, okay? And as you've pushed them together, that sedimentary rock, so your towels, has actually ended up folded and wrinkled, and it's pushed up. And what you can see is this high point here has gone above the tectonic plates. That would be the top of our mountain there as it's pushed all the way up through the ground. And you can see that it might create more than one ripple, so it might create more than one bump to your mountains. So if you can have a go at taking a picture of your experiment and having a label of it, or even drawing your experiment and just explain what you noticed. Now, to build the fault block mountains is a little bit more difficult because we would have been able to do this in school quite easily. So this is an experiment that's entirely up to you and your parents or guardians at home. Now, make sure you wash your hands. It's really important you have clean hands. Now, this might involve a little bit of baking, okay? So, I'm sure you've all seen the marshmallow crispy bars, or you've all made Rice Krispie cakes. And what you can do is with a rectangular tin, you can make a slab of this chocolate crisp, okay? So you can have your chocolate, bit of butter, and you can have your Rice Krispies. If you build that block, that's going to make your tectonic plates. Okay, so it's going to make the big earth plate underneath. And if you pull both sides of it apart, what you'll notice is the middle part might fall. If you were to push them back together again, then you might notice that it might pop that middle bit that fell out, and it might pop it up, and you'll be able to see that formation of the blocks, okay? And you might want to have a go at considering these questions of what happens to the rocks in the middle. Do they fall through? Or do they maybe push up? If you then push them back together, would they move up or down? Would all of the rocks then have moved downwards? What would have happened if you then tried to push those plates back together? And make a note of anything else that you find interesting about your experiment. Now, I know those are not the best activities to be doing. Ideally, had we been in school, there are lots of different things we can do, but I have to be wary of the resources that you guys might have at home. But the easiest one I think to have a go at will be the first one. If you feel like you're a little bit stuck, there are lots of videos on BBC that you'd be able to have a look at as well. But I think it's important to have a go at experimenting yourself so you can see how it works. We will have a recap of this in our next lesson where we move on to looking at our plateau mountains and our volcanic mountains. We're going to move on and have a look at the last three. Okay, so go off and have a go at that. Make sure you take some pictures of your experiments for me to have a nosy at, and just have a go and see what happens with your experiment. Now, I have also sent home what we call a knowledge organiser. So this is a document that sums up all of the knowledge that you need to know about this topic by the time we finish. So this specific page has got a little bit about our mountains on it. So there's no need for you to necessarily print that off or do anything with it if you don't want to. But it's a resource that's been sent home for you to have as a copy for you to look at, okay? So have a go at your experiments. Let me know how you get on. If it's not something you can do at home, do not worry, because we will do another further activity when we finish this lesson off next week anyway, okay? So go and have a little bit of fun with it, all right? Good luck, Year 5.